There it is. Okay. Hold on a second. Yeah, it's just going to show my control panel. I don't really care about that, I don't think. So, whatever. Okay. That's a start, I think. So this stream is basically just about me coding my own chess in C#. It's my first project in C#, and I'm mainly doing it because I can't hold myself accountable otherwise. So I just gotta do it like this, stream it. So, just for people to get a kind of idea of how well it works now, I take around, what's that, 17 megabytes of memory, so probably on release that's going to be a bit better when we build everything. And it works fine, I'll have to say, though as you see by the to-do list, there's definitely quite a few issues, I would say. Like, for example, that. So there's still a lot to do when it comes to that. And so the first thing is obviously I'll go a bit over the architecture I have going on. So there's actually nothing in Program CS, which is kind of weird, I know. But essentially this is a form application. It's using the Windows Form library, Windows WinGUI. Or was it WinForm or something like that? And it's essentially the inbuilt C# system of, well, it's not C#, it's like the inbuilt .NET system of talking to the library that just runs natively on all Windows computers without any like difference or whatever. And so that's over here. And so actually if you want to look at where the project starts, it's right here. There's a few things here that I don't really like, but this isn't the code anyway. These are all the click sort of things, the click functions, the event listeners, and I'll definitely change those for a dynamic event listener system because I need to have. One of the things I plan to have is essentially an n-by-n board, so you can like get as many fields as you want, really. Because right now we have the fixed 64 fields. They're all of fixed color, they don't change. That's fine, but sort of my preference would be that I get like that I can do something like 2x2 chess or 20x20 chess, so people can actually toy around with this thing. Making AI for that as well, that's going to be hell on earth, but I don't know, we'll see. We'll see how that goes. That's totally off, like that's at the end of this to-do list up here at the corner, and it's really not planned at all. I don't know if this is visible at all, if this can be easily seen. Maybe I could, hold on a second, I have an idea. Game capture, I mean, I guess I could say this is a game, right? Probably gonna recognize it as such. Form 1. Capture audio, no. Limit capture frame rate, no. So if I make an input on, is it gonna work? No. No, it won't. Okay, well that's a bummer, I think. Shit. Alright. Never mind, scratch that. I wanted to make it like a bit more easier to see. So I don't think it is quite easy to see here. But as you can see, I can't really resize the window. Maybe that should be something I'll work on. Although I'll see. But yeah, that's the project so far. Let's start squaring things off. And the first issue I have, I think, is to fix the, what was the function? Filter moves for occupancy. This function sucks. Mostly because it's not really clear what's going on. And also because, as you saw, it doesn't really work. So I think what I'm missing here is, so this is, it's essentially doing a check to see whether the piece is one that recurs the moves. So essentially those are pieces that cast moves instead of having a set amount of moves. So for example, pawns are not those types of pieces, but bishops are. As you can see, their number of moves can vary, and essentially they just say, oh, it can move in this direction. That's how most pieces in chess behave, or at least the important ones anyway. And so this is not good. Obviously, you can see that it's casting through. I thought I fixed this, and I think I did for a while, but then I started reworking how pieces would declare the moves they have. And I think that's where things messed up. So we're gonna fix that right now. So what this function does is says, okay, here's a temporary list. I hate lists too, but it works. So here's a temporary list that's gonna essentially hold all the moves that this piece can make. And you can see here, if selected piece is a recurring piece. So in the cases that it's bishop, queen, or actually what I plan to do, custom pieces, any piece that has raycasting logic to determine movement, then we have like this system, which essentially says, okay, I guess the problem with it is that we don't have a rigorously defined diagonal. That's kind of the problem here. So I have a Boolean here, encountered piece, and is along same diagonal actually. Wow, okay. This is gonna suck. Hold on. This is really gonna suck. Okay, so it says if it's not a new diagonal and it is the same diagonal, right? You know, encounter piece is false? That's not a presumption I can make. What the hell? I think I found my issue. What was I even supposed to do here? Oh! Is that gonna work now? Hold on. I feel like that might be the issue. Let's see. Everything is working fine so far. Oh. I'm not occluded by any pieces, hold on. No! Okay, no, we got this part to occlude. We got this part to occlude. I think that's good. So what's our problem here then? Yeah, we can't just set new diagonal to be true because we're not at a new diagonal, right? But that's what this code would have me believe. Okay, let's just go. Okay. I feel like maybe it would be better if I have an idea. I really want to make a better debugger for this program. I feel like whatever I'm doing now is just not, it's not sufficient. Oh, okay. I'll delete that. That's no reason to be there. This is fine, honestly. This is the for the pieces that have rigorously defined like offsets, that's fine. Don't really care about that. We're going to delete this very emphatic to-do comment because we're doing that. I feel like I should treat attacked fields differently, right? That was the idea I started with, then I changed it. Maybe I should bring that back. So let's bring that back. Let's bring that back. Okay. We have here if new diagonal, same diagonal. So if this isn't declared to be a new diagonal, and we're not along the same diagonal, then make it a new diagonal. That's perfectly reasonable. Otherwise, it's not a new diagonal. And I feel like here we should probably say if encountered piece and not new diagonal, just continue, right? Because we know we won't find any piece. We know we won't find any moves behind if we are on the same diagonal. We've already encountered a piece prior to that. So that's a nifty bit of code, I think. Skip a bunch of loops. It actually skips the biggest one, indeed. Okay. So now that this isn't the case, we should also false. Because we've encountered, you know, we're on a new diagonal. We don't know if we're going to encounter a piece here or not. If encounter piece and not new diagonal, continue. And then otherwise, because, well, this is going to continue. We're not going to get to this part of the code. I don't need to type in else. We say selected piece, and if the piece isn't null, we'll say we've encountered the piece. I think that's reasonable, right? And now I have this extra bit of logic that I suspect is the problem. So if we haven't encountered a piece, or the piece isn't null, so we've encountered a piece, and the encountered piece, what? Oh, encountered piece and selected piece is not the current move color. Add to input fields. I feel like that's a horrible piece of code, right? If you don't get a software engineering job, you'll be homeless. Okay. Thanks. Sure. Okay, let's see if that patch works. Hey, listen, man, I think you're just a hater. That's my opinion. Yep, there we go. That's our fix. So now, yep, there we go. Beautiful. Ignore the fact that the pawns simply are not working. We literally have to redefine how pieces work in order to get them working nicely. What's this here? This is probably not the best practice, seeing as there's a lot of random memory access. Keep up the good work. Yeah, chump, you need to go work back at your company. Go. Go be a cog in the machine. Why don't you do a stream, man? What's going on? You should do a stream. To do, this is probably not the best practice. Owing to repeated references to the input piece object, maybe a cast struck with a minimum footprint in the sill. Yeah, I should probably do that, what this thing says. Although, here's the issue. I can't really do that. Because what would even you... Well, I guess a piece's location would uniquely define it. That seems right. So I can't have more than... For now, I can't have more than one piece on a field. I don't know, we might do some exotic game mode where we do. It is a really funny concept. To do is dismissed. Social, yeah, we should update this. Enemy inclusive ray occlusion is now complete. So let me edit that here. There we go. One thing is squared off. Move blueprint encoding. Oh God. Yeah, that's a really big problem. Okay. So right now, if you take a look at the night, for example, I think that's the best example. You'll see we're going through a lot of hard coding, as you can see. Now this is probably fine if we were just doing the basic pieces in chess, but as referenced before, maybe that's kind of like not exactly what I want to go for. So I don't know. I guess we could get started on that, I think. I think we could get started on that. So the idea is that I create a text file that somehow encodes all the data about a piece. And also that idea sucks because I can't just have one file because I also need the image. Can I define my own like file format? Is that a thing I can do in C#? Yeah, I know it is, I just don't know how to exactly do that. All right. What else do we have on our to-do? Because that seems like quite a big complication. Claim-dependent pins and conditionals. Okay. So, first of all, in order to get that working, we need to get a debugger working for claims. So, just as a quick overview of how things work right now, the field definition has basically a list of structs, and they're called claims. And these claims, as you'll see down here as they're defined, we have a claimant, which is a piece, and is raycast claim. So, is raycast claim, that could essentially be defined as claimant dot is recur piece. That's basically how you can do it, but obviously not in here. And that's actually how I do define it up here. To do, if the bottom to do is to be done, use this method to match claim struct exactly. Yeah. Okay. Input piece, I++, unreachable code. Well, yeah, kind of unreachable code. But we need to now develop an actual good way to get the claims out. And I think over here I have, yeah, I don't have get claims, do I? No, I do have get claims actually. Wow, okay. So get claims is going to be returning an arrayed, like a to array converted list of claims. So let's go to board. Let's go to our debug, move debug info. And now move debug info is getting a change because we're now switching between input types. Switch input type. Oh, or current input type actually would be, yeah, that's the global variable I have. So case input type, I think reselected piece and selected piece would have the same logic, right? Because this is actually a move, if I'm not wrong. No, it's not. Hold on. No, it's not. I don't have a move there. Yeah, I don't. I don't have a move. I have essentially just the allowed piece. So this is actually selected piece, right? So switch current input type. Case input type selected or reselected piece, and that just cascades down to selected piece. Selected piece, and of course we're gonna have a default, which is just a break. I don't care. Or yeah, I guess we should do output string equals input type error, just to let us know what's going on, and break. Okay, here we're just gonna do what I just showed. So when we say selected piece, we obviously don't have to check whether there is a piece because that's being done for us in the upper function, so we can get rid of that. That's quite nice, I think. Control cannot fall through from one case label to another. What do you mean it can't? That's literally what I did up here, right? Where was it? Oh, down here. Yeah, look. It's literally the exact same piece of code. This is driving me nutty. Case, input type, selected piece. Oh. Down here. Scusama, please. Okay, so that's how it works here. But I also want to obviously add input type dot null selection, in which case we're obviously going to get some weird things. So we say input type null selection, and I actually just want to say, yeah, input type, that works just fine. Output string plus equals field, and we should obviously do the dollar sign. And just add the break at the bottom here. We don't need to worry about that. And obviously field or current. How should I get the current field? Selected piece doesn't really provide a lot of info. Selected piece, dimensions, chord pair. Let me just add like a selected field. Just that. And then I'll say selected field. Where is it? In, was it like click or receive click? Yeah. Neutral move request. Receive click. Oh, determine input type. Yeah, that's what I'm looking for. Determine input type is being called. Oh my god. Is this just F12? F12. Thank you. F12. And then in here, I'm just gonna say sneak a cheeky little case input type null selection selected piece equals selected field. Is that equals or dot selected field dot row equals. Oh no. There we go. It's a little cheeky, but it works. I think that like a cache is basically selected field dot row selected field dot column. Yes, and I know the column's not spelled with two L's. Thank you very much. Claims, and I'm obviously going to say claims, and then just field selected. I should say fields selected field dot row selected field dot column dot get claims. Whoa. So I'm wondering how that'll actually look like. I don't know. Let's see. So in this case, we get return output string just fine. And actually, the pieces have no claims so far. Yeah, it's going to throw us an error because there is actually nothing here. Yeah, I'm going to add a clause here, since that's probably going to happen a lot. If claims is null or claims.count is 0, then we're just going to return null. And then otherwise, we're going to return that. Fine piece of code, really. It just gets over that issue of passing a null to a method. So yeah, in that case, now, if I click here, claims are null. That's probably not good. Hold on. Let's move some of these raycasted pieces to who absolutely should have claims. And they don't have claims. What the hell was that? What? What am I doing? Oh my god, what is that? Hold on. I need to see this. I need to actually debug this. Do I have some kind of way of, hold on. This is so weird. Input type error. Why? Okay, I don't get anything by just spamming. It's not... It doesn't work anymore. What was that? What? Oh, wow. Okay. That's not good. Not at all. I think I have an issue with how I do my, like, move discernment or input type discernment, so we're just gonna have to check that. Receive click. Okay, yeah, hold on. I'll just say current input type, and we're gonna add that to the watch. This is just the only way we're gonna get around this, I think. Add to watch. What the hell? Guys? I said debug. Do I seriously have to do... Yeah, I think I do. I think I do have to do that. Hold on. So receive click is gonna hit right now. I'm gonna say current input type add watch. There we go. And now I'm just gonna say continue. Okay, selected piece. Okay. Why is it saying input type error? Reselected piece? No, not reselected piece. That's clearly not what just happened. Okay, I have an issue with how I handle my things. So when does we first of all need to determine whether it's maybe like a debug function thing. Move debug info is called. Is it gonna bring me to references? Yeah, over here. Yeah, in the conditionals. After the click has been made. What would that actually mean when I get fucking ghost movement? That's really weird. Okay, maybe after move piece, I've just got to buffer it out. Let's do that. Move piece, cycle move colors, and I'll say current input type equals just input type dot null selection. Might that get rid of our issues? I think it might. Let's try it again. Here we go. Up over here. And bishop. What? There's not... This is so weird. There's actually nothing going on with the piece that's telling it to move. Okay, hold on. Now this is gonna be the definite test. Is it going to call the function move piece? It will. Why are you calling neutral move request? Neutral move request. How is that a neutral move request? What are you requesting? Oh, I think I know. I think I know. Let's try now. Let's try now. I think that was the problem. It's weird how it never came up in testing before. I'll remove it for now. Continue, please. Well, actually, yeah, it was the bishop here, so let's just move this guy out of the way and then... Yes! That absolutely was the problem. Yes! Good! We fixed that. That was so weird. It must have been the fact that the selected piece was matching up with some conditional I had for enemy color conditional and move piece. So that was why. That's good to know. It's good to know we fixed that. You know, I should probably do a debug tool as well to highlight the selected piece with blue. What do you mean we, Bane? Where's your code here? Return 0? I don't see a return 0 anywhere. Okay. Okay. We fixed that. What were we even working on? When I say we, Bane, I mean the voice in my head tells me to do C#. It's called my brother. And he's really becoming a bother about it. Claim dependent pins and condition. That's what we were starting out with. I so remember. Okay. We need to add claims now. We must add claims. Okay, I think the biggest problem is that I initially don't have claims. So we should probably do that. It's going to be quite costly, I think. Will be quite costly, actually, for sure. And here's another problem. Claims need to be occluded by... Yes. Oh my god, that's gonna suck so much. Claims need to be occluded by friendly pieces, but not by enemy pieces. Oh wow. That'll suck. Really, it will. I mean, there's ways to get around it, around updating claims after friendly pieces move, for sure. But that would require redefining what claims are. I never thought it would be this complicated. I really didn't think it would be this complicated. Alright. Well, let's start from square one. We're not having any claims right now, so I think we need to fix that. First of all, like that, we're simply going to set up claimant, and then claim array at i.claimant. That's it. I don't think we need to display the whether it's array cast piece. We know whether it's array cast piece. For sure. Let's see if this thing fixes anything. I hate this. I hate this so much. Oh man. There really are no claims. That's so weird. So move piece calls remove all claims of, but also says add claims. I'm not sure what the hell this means. Add claims. Return all possible moves. Let's see if this even gets called. That's what I'm interested in. Does add claims even get called? Yes, it does. Okay, so what's the problem? Return all possible moves. Return possible move locations, which are what? I think we need to examine that a bit better. Null. Why are you null? Let's see. Let's see here. This is the problem. So actually this piece of code got ran when we moved that pawn forward. So selected piece current location, we grab that, we set it to null, we remove claims of the input piece. We should probably set that before this. Just in case I changed something earlier on. Simply makes sense. Then we set the location. We set the fact that we've now changed locations. We set the piece to there. Selected piece, increment move count. That all makes sense. And selected piece, return all possible moves. Okay. What happens when we call that? I think that's reasonable to ask. Okay, so it actually checks for... Right. It checks for all the pieces. Sorry, moves, which would happen to be in bounds. Returns them as an array. Add claims. Hold on. Okay. Also move locations, add watch. Yeah, it's an array of 2. Yes, that would make sense. And then all possible moves, or sorry, fields to claim is now null? Oh no, okay, here, okay. So what happens now? Fields to claim.length, add claim. Okay. Right. Okay, let's just continue without breakpoints and then examine what happened to our field. Debug view. No claim. How no claims? I don't understand. So they were clearly indexed in what we just saw, I think. Because they had to be. We were checking bounds, which means there is an internal reference to the coordinate system of the outer board in each piece, even though they're not technically connected at all. So that was a thing I fixed as soon as pieces could move. I know that. But I don't know what this is about. Why there are no claims, despite there being claims. Hold on. I will actually go here. Let me go for board. Go to our debug function. Here we go, move debug info. And we're just gonna see what happens there. Might be an issue there. Current input type, null selection. So we got that claim array. Is claim array null? Let's find out together. Claims is null? What do you mean claims is null? You just had claims on you. What? Oh my god. Oh my... This is so embarrassing. This is so embarrassing. There we go. Literally all of our problems are fixed now. Just look. Debug view. I'm gonna remove the breakpoint here. We don't need it for now. Claims, add new claim. Claims was null. Okay, this is a constructor issue, so I think this shouldn't be a problem. Yeah, it is a constructor's issue. Since we have here, we call, I believe, this constructor? And so we need to just say this is a new list of claims. So here we go. Third time's the charm, as they say. Okay, debug view, claimant, pawn. Beautiful, it works. And of course, we look back here, there are no ghost claims by what used to be the pawn. Also, I should probably clean up that display a little bit. It's claimant.getType.name, and that should just output pawn. We'll see here. Claimant pawn. There we go. Awesome. It works. That's good to know. So claims work. Now we need to get claims to be computed based on a few other conditionals, including obstruction from friendly pieces. So we need to get that working. And that's a little bit of pre-processing, I think. For sure. Since if you look here, we'll see that we have a filter moves for occupancy function, which is responsible for doing what it says. And here we actually have basically a unified filtering system, which does take into account occlusion by enemy pieces, but that's not what we want for this example. That's actually not what we want. Rather, we're looking for claims being obstructed by friendly pieces. But here's the thing. I think we should take it a step further. And I think for this, I'm probably going to have to go to Paint to explain something. I hate going to Paint too, but oh well. So, let's say there's a field here, and we have a queen on it. Beautiful cue, I know. And we have, let's say, for example, a bishop here, or a pawn. And on that same diagonal, we have an enemy, for example, an enemy king. Now, if we were to do occlusion, claimant occlusion by friendly pieces, our claim would stop here from the queen. And our pawn claims would extend here and also here. And here. And in the cases if we actually have special conditional claims enabled too, we'll have en passants here and here, but that doesn't matter for now. So our claim would stop here. It would just stop there, which I don't think is good. So, when the pawn, for example, were to move forward, which is a common move and it's one I actually really like, that's the discover check. So our guy moves forward. If I can do this. There we go, he marches forward. And now you'll notice, well, the queen's claim is now re-established. It's not a claim anymore, it's actually an active attack. This is a very consequential move. If we get this working, we get all mechanisms of checks moving completely. So we need to have a way of doing that. And I think the smartest way to do it is, of course, to ask the field that our piece used to be on, hey, what kind of claims do you have? Do you have claims from a queen or something? And obviously, just from a claim, we can't really know, you know, we're not really able to figure out, is it from here? is it from here? Because if it's from any other direction than the one I just illustrated, it's inconsequential. We shouldn't update it, of course. So maybe an occlusion counter, but the occlusion counter gets really, really stupid really, really fast, because like then we're actually like manually counting using diagonals, and that's really stupid. Oh man. But my question is this, right? Claimants, claims occluded by more than one friendly piece are directly inconsequential, but they are indirectly consequential because later on in the game they may become one piece occluded claims. So I think we're just going to have to bite the bullet on this one and simply go, hey, claims are now directions. And in this direction, which we can then dynamically count, we have these following pieces. That's just so scummy, though, don't you think? This is really turning out to be a problem, I think. Wow. Wowzers, as they say. All right. I'm just figuring this out. This is going to take a while. Okay. Okay, I figured it out. We should have it occluded by friendly pieces. But then those friendly pieces will call the piece, yep, that works. We'll call the piece that the claims are from and say, please recalculate your moves. Then the occlusion checking is done for us using the move checking pipeline. And then the king will find himself in a direct check. That's it. There we go. Okay. We have here what was being done. Again, this has the potential to balloon in quite a lot of recalculations that are maybe unnecessary, and especially when we're going to be doing AI move doing. Maybe it's not the smartest idea, but it's fine. I think it's fine, simply because we've optimized the move searching quite a bit. I think it's quite fast. And besides, we can just chuck it in another thread if we ever get overwhelmed by the computation time if we do things sequentially, purely sequentially. Because, you know, what fun is a game of chess if you had to wait like 7 minutes for the AI to make its move or something. So, claims. We need to initialize our claims, but we need to make our claims work. So, right now, I want to check how claims are occluded. So I think they are occluded. Since if you look at the debug view, the only claimant is the pawn. But if I make a move by the queen, yup. See? Claimant queen. And also let me fix that display once again. Here, claimant, get type name, break line. Yeah, so there's currently 2 pawns claiming this field and a queen. Okay, that's good. That's good. Okay. Now, we need to have Oh wow, this is gonna suck. We're basically, so this is, if you look here, we say encountered piece, selected piece, this conditional makes sure that enemy pieces occlude after them, but not them themselves, so we can like actually take pieces. But as you'll see, that's not really the way it's gonna work. We're gonna have a little bit of an issue, I think. So let's go over that, I guess. We're gonna have to make that same system, but for here. So what's gonna be our solution? I think we're gonna need to have more lists. Yeah, we're gonna need to have 2 lists. This is gonna suck so much, actually. Claim specific. Hmm. Hmm. Okay. Whoa. Whoa. Hold on. Okay. So, again, very similar system. Oh, wow, hey, look, I'm an idiot. God damn it, dude. Alright, there we go. Now, my question is, of course, did we break anything? So, that's the first thing we're gonna check. Yes, we did. What's the problem? What's the problem? Actually, what is the issue? What are we doing? Oh. Oh, no. Oh. Uh, okay. Awkward. Maybe I wasn't that big of an idiot, so I needed that conditional. But maybe now I'm a bigger idiot. Let's see. Yes, please, thank you. Yes, beautiful. We have things working now. Very good. Is this a bit redundant that we're doing it twice? Yes, yes it is. But it's fine. I'm sure it's fine. Anyway. Now that this is done, we need to actually do something with claim specific. And I think we're going to turn to our friend, the buffer, or I guess cache. Essentially, we're going to define this lazy variable, this no good variable that you should never ever do yourself. And I'm going to lose my heading in the code and struggle to find where I am. And then I'm going to say claim specific fields equals claim specific to array. Boom. Now, this is all pretty interesting, I think. But the biggest thing now is that we can now say in our move piece, or actually add claims here they are. Return all possible moves. We're also going to say claim specific fields dot length. Now, yeah. We're just going to do the same thing here, but of course with not fields to claim. Oh. Hey, hold on. um. Hmm. I'll just do it here. Claim specific fields. Wait, yeah, I'm triply dumb, I think. I'm triply dumb, since I don't really have to buffer this at all. Claim specific fields dot length I++. Fields at claim specific fields. Specific fields at I dot row. Claim specific fields at I dot column dot add claim input piece. We know it's going to be the same piece, and of course here I'm going to do this cheeky thing where I clear the whole array. Simply to make, make sure it's empty. So basically, we don't have to do it multiple times. We simply know that when we're adding claims, we can refresh the claims and they won't matter otherwise. So that's fine. Now, we probably need a piece claimant visualization, but I'll try without. So again, same input, same system as before, but yeah. Two queens can't claim that. What do you mean? Now, which queens, though? That's the problem. This isn't really telling us. Okay, let's add the queen's color, I think. Or, no, better yet, queen's location. That's miles better. Or actually, any piece's location, for that matter, of course. Claimant. Location is piece, or what was it? Claim. What? Oh, that. Plus, location at claim array at I dot claimant dot get location dot row dot column. Yes, guys, debug tools are horrible, especially when I make them. Anyway, let's look at this here. Claimant pawn at location 3-3. That's no good. Okay, I feel like this should be universal, don't you think? Yeah. So let's just delete this case completely. And we're just gonna lob it out here. Since we know that we're always gonna hit this case, I think it's fine if we just say, do this for every, you know, makes sense. Okay, so we're seeing a little error here where essentially it's saying, you know, like, let's do, wait a second, I mean, I already checked for that, right? Fucking hell. Oh. I already checked for that. Claims. Field. Why isn't the pawn a claimant? This pawn should be a pawn should be a claimant, right? For sure. What's going on? Okay, hold on, let's just do the queen. Queen at location 1, 3. Yes. That is accurate. Claimant pawn at location 3, 3? What? Oh, wait. I don't think... Hold on. This is so weird. Selected field. Oh! I see why. Selected field isn't being updated when we click. Selected field isn't being updated when we click, so let's do that. Let's do for any click. I mean, if we receive a click, and this function's in here, I know that. AI? Yeah, no promises, but that might be a thing. Get piece at cycle move colors determine input type on highlight move debug info receive click. We're just gonna say selected field equals click location for all cases. So we don't have to do it like, oh, is it for just null selection? That simply is the case. If we select a piece, we selected the field below it, that's for sure. 3, 3, 0, claimant on at location 4, 3. Yes. And now, queen at location 1, 3. So if we move this queen forward, queen at location 1, 3? What? Twice? What do you mean twice? Why is it twice? Am I erroneously calling the update function twice? Is that happening? I think that might be the case. Oh my god. No! I think that's about it. I quoted for an hour. And, you know, claims work. Let's just say they work. Hopefully they do. I think that was a display error. I think that was just a display error, I'm pretty sure. Since add claims, when is that called? Add claims is called on move. So it wouldn't really make sense to add the claims twice. I think. Hold on. One final thing. We're obviously going to troubleshoot this function just to make sure everything works. Okay, you work there. That's fine. You work there too. That's fine too. I don't have a problem with any of that right now. Okay. So you get called, and then I move this guy, and you get called. What? Is it getting... Wait. Is that the issue? Hey, that might be the issue. Yeah, that's the issue. Because I think what we're doing is we're saying highlight move fields in my filter moves for occupancy function. Oh my god. Yes? That's the issue. Okay. Well, that's for tomorrow, I think. So that's a whole other thing. We basically have to override another function. Okay. Okay, we're trying to get semblances. Of course, I'm gonna push this on my Git. So I'm gonna save that. There's my scribble. I need to commit first, obviously. Awesome. That's about it, guys. Cheeky little chess stream. I think tomorrow is the day we implement checks, finally. Or actually, hold on. Move blueprint encoding. We did kind of knock out claim dependent, so we're just going to do pins. Just pins. That's what we're looking for. Pinning a piece, and of course, checks and castling. So that's for tomorrow. The coding moves to algebraic notation. That's far out. We're going to get to that because custom pieces will complicate that significantly, and we'll have to check for congruent names and things like that. But for now,